Okay, so when you have an empty project, as we did every time, the first thing we're going to add a CUP file, call it source, and now we have a CUP file. Let's test that everything is working. Okay, everything is working fine. So when we start talking about classes and object-oriented designs, we basically trying to design a structure behind our code in classes. So what do we mean by a structure? So if we have, like we've already done that in the example of bank and accounts. I think I have that slides here. Yeah, so in this example, if you remember it, where we had a class of account and a class of, what was it, owner. This was a design between two classes in which an owner had multiple accounts. So the relationship here between the class owner and the class account is that owner has accounts. This is a relationship. And this relationship is basically called class composition. So whenever we have class has another class, that's a class composition relationship. So we're gonna look at some simple examples. So let's start with a class called farm. Okay, we have farm, and we're gonna create later a class of animals. Let's say, I mean, we can fill things up here if we want. I'm putting everything in the CUP file, but we've discussed that later last time, and like we talked about separating things between header files and CUP files, but just a simple, quick example here. So I'm gonna keep the farm empty for now, and let's add a class, call it cat, for example. Okay, private members. We're gonna give a name to our cat. And let's say in the public, we have a print function. Okay, and we need a way to we need a constructor also for the cat. Let's just make a regular constructor. We'll initialize it using the initializer list. It will be an empty constructor, as we've done everything we want, which is initializing the name. So there's nothing to do with the constructor. So we have a class cat, and we have a class farm. Now, a farm has a cat. I don't actually know if a farm has a cat. I should probably have picked a different animal, but let's say it has. So a farm has a cat. That's a relationship, a class composition relationship between the class farm and the class cat. And the way to translate that is by, what that means is that we are going to have a member as part of the farm, which will be the cat. So by having a member, which is a cat of type cat class in the farm, a member of farm, it means that farm has a cat object, or class farm has a cat object. And this is a relationship between two classes. Now, how can anyone describe this relationship in terms of like for example, for every farm, how many cats do we have? in this specific example. It's really a very simple question. For every farm we create, how many cats does it have? One, exactly. So this is described as one-to-one relationship, meaning for every one of this class, we're going to have one of that class, or an object of, like one object of the other class. So this is a composition relationship, and it's one-to-one relationship, because for every farm we're going to create, like right here in the main, we can create an object farm, and now this object has, okay, let's add a constructor. Let's keep it empty. Okay. Okay, so I'm getting an error here saying that there's no default constructor exists for class cat. And it is a valid error by the compiler, because there is no default constructor for cat. However, when we're constructing this object farm, and it will need to construct this object cat as well. So because we're not using the regular constructor for cat, or we're not initializing cat ourselves, it's going to try and use the default constructor. But there's no default constructor for cat, so it's giving us an error. Now, we can still use the default constructor for farm, but initialize the cat with, we're going to use the initializer thing. So we're going to use the regular constructor of cat. Let's call it. So now we're initializing the object cat, which is a member of farm, by calling the regular constructor of cat with a default value. So this is not passed by the user of the class farm. Like in terms of constructing an object of farm, we can only use the default constructor because that's the only thing we have right here for farm. Anyway, I'm going to add a breaking point here. Run this, and we're gonna look at the memory for farm. So inside the memory, which you can see here, we can see we have one object farm. The name of this variable is called farm with small letter f, and the type of it is an object of farm, capital letter F. Now, what's inside of it? You can see inside of it. Inside of it, it has one member which is cat, called cat, and the type of it is cat with a capital C. Inside the object cat, we have a string which is name. Like you can see, the variable of this is called name, and the type is std string. It has a type of string. And now we're looking into, like, string is a class by itself, and it has members and it has other things. And one of the members it has is, for example, size, which returns the size of the, like, it's an unsigned integer. This is the type of it, and it holds the size of that string, which in this case is 4 because we have 4 characters. This is the capacity. We can discuss capacity later. Maybe we can run an example also on vectors and learn more about this. And this is the character array, or not really, like it has the type of compressed something, but compressed pair. But it's basically the array that is holding the characters, which is these 4 characters. So this is what's inside our object string that is inside our cat object that is a member of farm. This farm object right here. And this is a one-to-one class composition relationship, because for every farm we're going to create, there will be one cat only. So now the question is, what other relationships can we have? Well, we can have one-to-many. And one-to-many means that for every farm, for example, we can have many cats. So how can we change our implementation, our design to have a one-to-many relationship? Our goal is to be, for every farm, we want to have many cats. Anyone can make a guess?
So would we then say that under the public, we would want to have maybe cat 1, cat 2, cat 3?
Okay, we can have cat 1, cat 2, cat 3, but would that be one-to-many, or would that be 1 to 3 cats? Like, is it a good design if every time you want to change the number of cats your farm can hold, you have to go and manually add objects one by one, and then if you want to access them, you're going to be accessing cat 1, cat 2, cat 3?
No, not really.
Yeah.
Do we want to be able to do it dynamically then?
I mean, we can use some sort of data collection, data structure to hold a collection of cats. We've done that with the example of accounts. We use an array and we stored for the owner 10 accounts.
Right, so we do the same thing, we could store like 10 cats instead.
Yeah, but there's a difference between making it like that, 10 of them, and being able to do an array of type cat and let's say size 10. The difference here okay, so cat 1, let's see. So the difference here is that, let's add a regular constructor for cats so that we don't have the, because I'm not gonna, so this is one of the problems, for example. Now I have to write for every one of those members separately initialize it all. I cannot initialize, I cannot have a for loop, for example, to go through all the cats in this example, in this design, by having them separate.
Right.
So this is not a good thing. I'd rather have a way to add a default constructor for cat. Okay. If you're doing a one-to-many design, you need some sort of data structure, a collection that will hold that many in one place. So an example of that will be such array, which holds members of or objects of cat and has a size 10 in this example. So like now, if you want to go through all the cats, for example, let's implement a print function here for farm. Okay. In your example, what I had to do is that cat1.print, cat2.print, etc., etc., etc. If I change the size of this array or of the number of cats I want to hold in the farm, I have to go to every time I'm using all the cats and just add more lines of code. The design will not be like able to generalize to a number, which in this case, like the size of the number of cats. But in this case, I have an array of cats. So what I can do is I can have like a for loop. Cats.size and call print for every cat. Now this is a for loop going through from 0 until I reaches the size of cats, which is an array, and incrementing by 1 every time. And then I'm accessing that array at element I, and I'm calling print on it. If I change the size of my array of cats to 20, everything still works fine. If I change it to whatever number, everything still works fine, because it's going to just increment this until it reaches the size, and size is changing based on this size. Now, this is one data structure that I can hold the cats in. In the example we did for accounts and owners and owner, we looked at the difference between having an array of like a pointer to an array and an array of pointers, and we discussed all those examples. So right now, what's happening here is that when the moment I construct an object of farm, I will have 2,000 cats being constructed, even if I don't necessarily need them. So can we use a different like data structure that would allow us to change the size of that collection as we want? Something like an array, but it has a dynamic size. Someone is suggesting vector, and exactly that, we can use a vector. So let's talk about what is a vector. First, I'm going to include a vector. So maybe I can draw somewhere. Okay, can you guys still see my my screen? Okay. Okay, I have a pen. Okay, so this is an array. Okay, actually, putting it. This is how our array would be stored in memory, let's say. It will be a bunch of elements on top of each other. Each element has the size of whatever, the size of an object of that thing that we're storing. In this case, like we have an array of cats, and each element has the size of one cat object. Now, when you're dealing with arrays, you have to specify the size at compile time. It has to know how much memory it's allocating and all that stuff. What a vector does is that it still uses an array, but you don't have necessarily, like you will not be necessarily dealing with that specific array. So instead of starting with an array of, let's say, size 200 in this case, because you're knowing that maybe this is the maximum number of cats you're going to have, a vector will start with an empty array. It will start with an array that it doesn't exist, maybe it's empty. And we're going to add the first element. So when we're adding the first element, it was going to create an array of size 2. It has 2 elements only. It's going to put our element here, and it's going to keep a reference of the size. Okay, this is bad handwriting. The size and the capacity. The difference between these two is that the size is actually the number of elements we have stored inside our vector, and the capacity is the size of the like back end, if you want, array that is storing the actual data. So there's still an array, and right now the capacity of it is 2, but the size of our vector is 1 because we've only used one element, or we've only added one element. Now, if we want to add the second element, we have a capacity for it. So as long as there's capacity, it's simply going to put that element inside the next empty space, which will come here. Now, what happens if we want to add a third element? If we want to add a third element, there's no more empty capacity in this like back-end array that in which we are storing the data in. So what will happen here is that it's going to create a new array, doubling the size of the previous array. So it had a size of 2, now it will have a size of 4. And then it's going to move these elements to this new array. So the size of the vector did not change. We still have only 2 elements stored, but the capacity of the array storing the data now doubled. We have a total of 4 elements that can be stored here. So the third element will come here. And we would have an empty space for a fourth element. When we add the fourth element into the vector, everything will work just fine. We are still within the capacity of our hidden array. But when we're adding the fifth element, the same process happens again. A new array is created, doubling the size of the previous one. So it had 4, now it will have 8. 3, 4, 5, 6, 7, 8. Now the array has size 8. Every element here was moved to the new array. And then the previous array was deleted. I forgot to mention this before. So the previous array is deleted. Now this is the new array that is holding the data of the vector. The size did not change because we still have only 4 elements stored because we added those. But the capacity of the hidden array now changed. It doubled. It's 8 now instead of 4, and before it was 2. Every time we reach an overflow in the capacity, it will create a new array doubling the size of the previous array, move all the elements into the new array, and delete the previous array. And this is basically how a vector works. It's a simple like data. So in the next course after this will be data structure and algorithms, and you will learn more about data structures. Obviously, it's the name of the course, so that's everything you're going to be learning. But this is like the very basic first data structure that you will learn. Any questions about vector? We will see it in action now in C++. But our vector is a class of dynamic arrays. So when you say class, you're not talking about like in as a C++ class, like as software class, right? You're talking about like general English as in class of dynamic arrays, right? Okay. Yeah, maybe you can say that. Like dynamic arrays, maybe it's just like the term, I'm not sure if the term dynamic arrays would be, or expandable arrays. Let's check out. Yeah, dynamic arrays. So you will see that they have many like different names, even if you're, so this is an example of such a dynamic array, which is a vector. Like in C++, it's called vector. In Java, it's an array list. There are different names for it, but it's an expandable array or a dynamic array. Okay. So going back to our cats example, let's use a vector instead of an array. So instead of std array, we're going to use std vector. Now here we're not going to specify the size because the size is going to be by default. I'm not sure if it starts with 0 or it starts with 2 elements, and I'm not sure if it's defined in the standard like guidelines, or is part of the, like it depends on the compiler to decide, like the compiler designer to decide. But it's gonna start somewhere, whether 0 or size 2, something small. And so this will still work actually as is, because vector, just like an array, has a member called size. And this is a for loop going from 0 until it reaches the size of this data collection, which is a vector in this case, incrementing by 1. And we can access the elements like that. So right now, if we just call print, it will not cause a problem. If I call print on farm, it will not cause a problem even if I don't have any cats, because the size will be 0. We can still have that breaking point and look at the memory. So this is our farm. We have cats of type std vector that has an object of cat. And the member of cats, the size is equal to 0. Now capacity is also equal to 0, which is interesting. Let's add some elements to our farm. Let's add some cats. So let's create a public function here, add cat. And it's going to take a cat object. Let's pass it by constant reference. And we're going to use a function on the vectors called pushback. So pushback basically is going to push that element to the back of our vector. Like at the very end, it's just going to push it back. The term pushback is used in the C++ library for vectors, mainly because it really means like it's not just incrementing or adding. It might be moving to a new array and pushing it back. That's like why the term pushback is coming in. It's different than like insert. You're not just inserting to the array. You might be changing the full capacity of the array. So let's just create an object here of cat, call it 1. And actually, why am I doing that? I should be passing what we passed in the parameter. So we're already passing something to the parameter. So we're just going to pass it to this pushback. Like we're passing an object of cat to the add cat function. And we're just going to push it back to the array, to the vector. So what will happen here is that it will make a copy of it. It will not be, it will not take this, because this is passed by constant reference. And the way we're passing it here, it will make a copy of this cat. If this vector was holding pointers, for example, and we passed a pointer, then it will make a copy of the pointer. So we will have a reference to the same cat inside the vector and outside the vector, because we're dealing with pointers. But as long as we're not dealing with pointers, this cat will be a copy of whatever cat we're passing. Okay, now let me add a farm.addCat, and let's create a cat object here. And I'm going to run this again, and let's look at the memory this time. Okay. Size equal to 1, capacity is equal to 1. So we started at 0. We added this. We added a cat. Now we have size equal to 1 and capacity is equal to 1 as well. Let's add 5 cats. Now size is equal to 5, but capacity is equal to 6. So we added the first one. It changed the size of the array to 1. We added the second one. It doubled. Now we have an array of size 2 or capacity 2. Added the third one. We had 4. Actually, I'm not sure how if it doubled everything. So it's 1, 2. I think at 3 it doubled. Like it probably after the 2 it maybe added 2. Let's test this. Let's find out after the second element what's the capacity. I'm going to add a breaking point to every one of those so that we can look at the memory at every step. So we are, before we added any cat, the size is 0 and the capacity is 0. So I'm going to step over this line. I pressed the button on top of the IDE. I stepped over this line. Now we're at line 44. The size is 1 and capacity is 1. Step over again. The size is 2 and the capacity is 2. Let's add another cat. Size is 3, capacity is 3. Let's add the fourth cat. Okay, size is 4, capacity is 4. Now size is 5, capacity is 6. So it didn't necessarily double all the small values. Let's add another one and see what happens after the 6 and 7. I think I stopped sharing my screen. Okay, now we're back. Okay. So now we have size 5 and capacity 6. We move one more step. Size 6, capacity 6. One more step. Size 7, capacity 9. So, okay, it's not necessarily doubling in this case. I'm not sure exactly how it's moving, but it's increasing in size. Like the basic example that's usually used in dynamic arrays or expandable arrays is doubling, but you might have different implementation in which it's not doubling the full thing, but doubling part of it. Now, the real question is, let's say I'm adding 1,000 cats. Is this a good thing or a bad thing? What's happening right now, like what you're seeing right now? If at every step we reach the maximum capacity of the array, it has to create a new array, move everything to the new array, and then delete the other array. And I'm doing this starting from 0 until I reach 1,000 or 10,000 or 1 million or whatever it is. Would this be a good thing or a bad thing? Okay, someone is saying bad. Can you explain why it's bad? Exactly. In this case, we have to keep resizing. We are creating new memory, moving memory at every step, and then deleting the previous memory. And we're doing it so frequently because we are storing a big number of cats and we're starting very small at 0. And then we are just resizing at very small steps. it's going to take so many steps of resizing if we're going to reach 1 million. So when you're dealing with vectors, if you know that you're going to use a lot of, like you're going to store, let's say, at least 200, for example, or something, like whatever number it is, you know that you're going to store a big number of it. What you can do is that you can specify how much memory you want to reserve at the beginning. So I'm gonna put it inside the constructor of farm, and we're gonna call on the cats vector reserve, and let's say 100. So what that means is that we're reserving basically a place for 100 objects of cats inside that hidden array. We're doing it inside the constructor of farm. So the moment we are constructing farm, it's going to resize the hidden array of the cats vector from 0 to 100. So our initial size that we're starting with will be 100. So let's first have a breaking point here, just to see the initial size or capacity of the cats. And then we're going to have a for loop and we're going to add cats 100 times in this case. And then we're gonna have a bunch of add cats again, but they will be one by one, so we'll be able to add breaking points. So I'm gonna add a breaking point here and breaking point here. So first we're gonna look at the capacity of the vector when we first construct the farm. And then we're going to add 100 cats using this for loop. It's going from 0 to 100 or like till 99 and incrementing by 1. And at every step, it's adding a cat. Okay, so at the very beginning, so before it didn't run the first line. Now it, like I stepped over the first line, so it ran the first line. We have a cats. This is the vector cats. It has size 0, but capacity was changed to 100 after running the constructor of farm. So the underlying array that is holding the data now has a size of 100. So when we start adding elements, okay, I keep pressing on stop. I need to change the location of this. Okay. If we start adding cats now I'm stepping over lines, and we're gonna go through the for loop. So we added, by the way, this is excellent debugging tools to use. I can see what is the I variable here. I is 1 right now. And I can see the memory inside cats and all that stuff. So cats now has a size of 1. I can even look inside the array of the vector and see my cat. This is my cat. It has a name, which is meow1. We gave the same name for everyone. Actually, let's run this example again and do this instead. I don't know if this will work. We'll find out, because we might need to change it to a string. Well, someone is asking me, how did I display that debug tool? I added a breaking point here. So when I press here, it added a breaking point, which means that the code will, like the environment will stop here. It will not continue running, and it will show me what's inside the memory. Like all of that just happened when I pressed run. You can even on the right side here, you can see how much memory you are using. You can see how much memory you are using. And you can see, by the way, that our memory jumped, although we've only added one cat, because I'm going to rerun this and we're going to look at the memory again. So at the beginning, I just started first line. I don't have any memory, or I'm not using much memory, like barely anything. After running one step, okay, now I'm not seeing the memory anymore. Okay, for some reason, it's not showing me the memory anymore, just like it was showing you before. It's not taking any snapshot of the memory. Anyway, I think it has to do with, actually, no, there is something here. Okay. So it's showing me the, like a small private bytes that I am using. This is the CPU, the process memory. You can even have a, like a snapshot of the heap, by the way, which you probably can, like, you can enable it. Okay, I just enabled it. So this is like a snapshot of the heap, which I told you before, like like we talked about pointers and how to access heap and all that stuff. This is like a snapshot of the heap. So if you have pointers on the heap, it's a good tool to check if you have memory leaks. This is CPU usage. Anyway, there's a lot of advanced tools here. There's a lot of advanced tools here to check out. So, and they are different between every IDE. So you have to get used to the IDEs you're using. Anyway, when we're adding these cats here inside the this for loop, the size of our array of our vector is 13. The capacity stays 100. So we're not doing a lot of we're not changing the capacity of the array. We reserved 100 cats at the beginning, and then we kept adding. Now what I did, I stepped out. I just pressed step out, which went outside the for loop. So it just ran through the whole for loop, and now I'm out of it. My capacity is 100, and my size is 100. So what happens now if I add a new cat? My size is 101. My capacity is 150. So the steps that we moved is like right now we've resized only twice. At the very beginning, we resized to 100, and then we resized 50 more. Although we just added one, now we jumped 50 more. If we cross over those 50, it's going to resize at a bigger step. So if you know that you are dealing with a lot of data and you're going to be storing a lot of data, and you're using a vector, make sure you reserve some space before you start so that it doesn't keep on resizing at very small steps. Anyway, so this design would be a one-to-many composition design, because every one farm has many cats, or zero-to-many cats if you want to be specific. It allows it to have a 0 cats. With this design, it's allowed to have 0 cats. So it's 0-to-many cats. And the key word here is that it has. Whenever we're dealing with has, like this class has objects of the other class, we're talking about class composition. If we're just having a cat object like this, then this is a one-to-one relationship. Every one farm has one cat. If we're having some collection and we're storing multiple objects, then this is one-to-many relationship. Every farm has many cats. Or in this case, like if you want to be more specific, it is 0 to many cats, because it allows it to have 0. And you can add dynamically whatever you want, number of cats. Now, there's the other, like the third type of relationship, which is many to many, but we're not going to go into it right now. Probably next tutorial, like when you already take inheritance, we're going to practice designing like some like classes for teachers and professors, like teachers and students. So every teacher will have many students, and actually, let's do it right now. I mean, I don't have anything planned really for this tutorial except for running practices. So if you want, we can do that example right now. Okay. I think there's more topics we might want to cover, like static and like friend class, but we'll do this example and then we'll go over those. So let's say we want to have a class for students and a class for professors, and a student has many professors and a professor has many students. So this is a nice class composition problem, because now we're going to face a problem here. We're going to see it in a bit. Let's add a header file for, let's say, student. And we're going to add a header file for teacher. Okay. Let's start with the student, class student. Okay. And we're going to have, from here, we're going to have, let's say, vector, just like we were doing before with the cats. And it has the type teacher. Although at this point, teacher doesn't exist yet because we don't know what teacher is. And let's make a default constructor. Let's keep it empty for now. And that's our student class. It doesn't know what teacher is. So we're going to go to teacher.h and implement class teacher. We're going to have similar things, public, private here. Let's say name as well. And vector student, because a class, a teacher has many students. Let's call it students. Let's include the missing libraries. So we're going to include string. We're going to include the vector, and we're going to include student.h. At the end of the class definition, you need to put a semicolon. Let's make a constructor here, default constructor, also empty for now. Now we'll go back to the student.h and we're going to include teacher, because now we know what teacher is. Teacher.h. Now it will be able to recognize this teacher. So I'm going to delete my main function here, like empty what I have in here for the cats and the farm and all that stuff. Let me comment this maybe. Okay. I mean, it doesn't matter if we keep it here, but I'm going to comment it just to Just show you that there's nothing interfering other in the code other than this. So I'm going to run this simple, just like right now we still don't have anything. Let me just, if you want, include, we can include the student and the class and the teacher, so we can create objects of them. Just very simple example in which we have this even empty main function. We have a class here for student, has an empty constructor, a default constructor. It has a string name, and it has a vector of teachers, or vector of objects of teacher called teachers. So, and teacher has similar thing, instead of a vector of teacher, it has vector of students. And let's compile this and see what happens. Okay, we have a fail compiling. We have a compilation error. It says undeclared identifier called student. So basically, the compiler is telling us that it's inside the teacher.h. You can read here teacher.h file. So the error is generated from here at 1614. So line 16, character 14. If we go to teacher.h, line 16, character 14, it's right here. This one here. It's saying that student here, this student, which is being identified, like it's highlighted, it knows what it is, we're including it here. It's saying it's an undeclared identifier. Student is not a valid template type argument for parameter. Anyone can make a guess why this is happening. I mean, why is it not able to see student? Or it doesn't know what student is yet? Try to think about how the compiler is reading the code and analyzing it. And remember, compilers are sequential. Like they're going to parse the code somehow sequentially. So let's say they start with the teacher.h file and they're reading the code from teacher.h file. They reach to the point where they see student. No, even if it's defined in a different file, like someone is saying that there's a linker error because student is defined in a different file. We are including student right here. So if we have a different file and we're including that file, that class, we should be able to use it. But imagine, like right now, the compiler is trying to compile this code and it starts with the teacher.h file. It comes to here, it sees that there's a student. So, okay, let me include student. It goes to student. Okay, there's a teacher. Okay, so let me include teacher. There's a student. Let me include student. It's like everyone is dependent on the other. So how can the compiler know the definition of both at the same time if each one requires the other one? And this is why we're getting this error right now. We have a class that is using an object of the class teacher, or using the class teacher, which means that at this point, teacher has to be defined. And then we have teacher class, which is using the student class, which means at this point, student has to be defined. And there's no way to define both because each one needs the other one to be defined before. And this is why we're getting a compiler. Now, the way to solve this is by something called forward declaration. And forward declaration means that we're going to tell the compiler that there is something called student, class student. We're not going to define anything in it. We're just going to declare that there is a class called student. And we're going to go to the student class, to student file, and we're going to do forward declaration here to a class called teacher. We're also not defining the class because the definition happens inside the header file, teacher.h. But basically, before the compiler starts going through the definition of the student class, we're going to declare to the compiler that, hey, there's a class called teacher. So if you see an object like in here saying it's using a class called teacher, know that it exists. Later you will define what it has, but for now, know that it exists. Same for the teacher. If it's going through the teacher, it has a forward declaration saying that there's a class called student. So now let's compile again, and it's working. The compiler was able to, because we did a forward declaration to these classes, it was able to know that, okay, student exists, teacher exists, I can continue parsing this code or compiling this code. So now this is a class composition problem, or like design, and it is many-to-many design, because a teacher can have many students and a student can have many teachers. Whenever you have such design in C++, like basically remember that you need to do forward declaration, because this is dependent on that and the other one is dependent on this. Even if it's not many-to-many, even if it's like as long as you need both classes in the same, like in every class, you need to do a forward declaration to tell the compiler that the other class exists. Is it clear to everyone what problem we were facing here and how we solved it? Anyone have any question about this?
You did a really good job of explaining it.
Well, thank you. Okay. So what time is it? We still have time. Let's run some. Okay. Do you guys have any questions about class composition itself, like before we go through other things that were covered in the lecture? I think you covered the static. I had these slides somewhere. Okay, I think you covered static, friend functions, and the this operator. So we actually covered the this operator last time. We might look into it now as example, but let's look at friend functions. So in short, friend functions are functions that are not part of your class, but they have access to your private members. Like I want to go to the example of the cat again because it was nicer than teachers and students. So we have the farm and we have the cat. Let's I don't know. Let's create any function here. So friend void anything. So now this function anything is a friend function to the class cat. It is not a member of the class cat. So even if I try to call, see, like I'm trying to call cat dot anything, it's not a member of this class. Cat has no member anything. So how do we make a call to a friend function? The best example for friend functions and like I'm pretty sure some of you, the ones at least one of you is going to tell me now, why the hell are we going to use friend functions? But like the answer to that question is going to be wait until you cover operator overload. And that's really, like, for me personally, maybe the only place where I've seen friend functions being used for a good reason. Other than that, like, I'm not sure like in what example, like cases specifically to use them. Okay, this is too much documentation, so let me just go out of here. Where was our cat? So let's just declare that this is a friend function, and we're going to define anything outside. And let's say whatever it's going to do. Actually, let's pass a member. So we're gonna pass a cat object by reference. The whole point is to show that we have access to the private members. So let's do cat.name. Like you see, even the IDE, like the Visual Studio already showed me that I have access to name now. It is a private member. It is a private member, name of cat. It's here right now, like right here, it's private. But I actually have access to it directly because anything, this function anything, is a friend function to the class cat. So you can notice that the function anything is declared as a global function in here. It's like anyone can make a call to it. It's a global function. It's not a member to any class. And we are passing to it an object of cat by reference, by constant reference. And inside of the scope, inside the scope here, because this function is a friend function, it's declared right here that it is a friend function to this class cat. We are able to access the private members of cat, which is cat.name. Like I can print here directly cat. Okay. I can directly print the name of cat because I have access to it. So let's test it right here. Let's say this is a new cat we just created, and we're gonna call anything, and we're gonna pass this cat. Let's run this example. And we can see the output here, test cat, and then we're outputting hello world. So really it's really as simple as this. A friend function to a class means that it's a function that is not a member of this class, but it has access to the private members. Friend class, like you can have a class friend to another class, and it means this class has access to the private members of the other class. Any questions about friend functions? Like I don't think there's more into it other than this, but like a good practical example you will see when we're dealing with operator overloads. And that's a nice tutorial is going to be by itself. Okay, let's talk about static members. I think last tutorial someone used the term static, but for different meaning, and we talked a little bit about static. So static members mean that let's have it here. Let's say static. So let's say we want to, for example, in this case, every time we want to create a cat, we want to automatically generate an ID for it, incremented by itself. So every time we create a new object of a cat, like instead of the default constructor being an empty string, I wanted to give numbers to cats and automatically increment that number every time. So how are we going to keep track of the cats globally throughout the whole program. Like maybe from one place, we can keep track of the numbers of cats and start passing things incrementally by ourselves. But what if there's another part of our code using cats as well, and a third part of our code using cats as well? And I want to make sure that throughout the whole program, from the initial runtime till the very end, I have a distinct ID for every cat object I create, regardless of where it is created. So such thing has to happen from within the class itself when I am constructing the object, and not from the outside where I am controlling it. Or like maybe you can control it from outside, but it's not going to be as safe as dealing from it from the inside. Like you're giving access to anyone outside to deal with the IDs. You want it from the inside to be exactly distinct, and no one can duplicate an ID. So what we're going to do here, we're going to create, like basically to be able to do that, we need to have some reference of how many cat objects we have created so far, and keep incrementing that number at every step. Every time we construct a cat object, we need to increment that number. And we also want that number to be contained within the cat class. Now, if we create an integer as a member, like let's say number here, this is going to be a separate integer every time we create an object of cat. So in the example that we had 100 cats inside the array, we're going to have 100 numbers, 100 different numbers. But what we want to have is one number only that is being shared by all the objects of cat and the class of cat, that like not every single object of cat will have access to that one number only. It will not create a number for every object. So what we're going to do now, we're going to create a static integer here. Let's call it number of cats, for example. And now this is going to be shared with all the objects of cats. Meaning it's one number, one integer that is part of the class memory and not the object's memory. So in the constructor, what I'm going to do in the default constructor for the name, what we're going to do right here is, okay, let's not use maybe the initializer list. Let's do it inside here. We're going to set the name equal to cat plus number of cats. So this is cat 1, cat 2, cat 3, whatever. And then we're going to increment number of cats. So at every step, every time we construct a cat using the default constructor, at least in this case, is going to name it cat with the number that we have based on number of cats, and then it's going to increment number of cats. And because this is a shared integer, it's a static, the second time we come to this constructor, number of cats would have been incremented because that's what we did in the previous construction. So the next cat will be incremented, and so on. Now, we're still missing one thing. Where do we start with the number of cats? How do we initialize number of cats? We can't initialize it inside the constructor of a cat because it is independent of specific objects. Like the initialization is not part of specific objects of the cat class. It is part of the global cat class. So we have to do it in a CVP file. So we have to initialize it outside the class by specifying that, okay, this is an integer. It is coming from the cat. This is how we would access a static member. It will not be a, like we cannot access it from an object. We'll try now to access number of cats from an object, but because it is shared with the whole class. So it's part of the class and not of a specific object. And with this line here, and it has to be done in a COP file, except for specific cases, I think, in the modern C++ specifically. But you will usually see most of the static things initialized in COP files, not header files. Anyway, so in here, we're initializing this number of cats to be 0, and this is the static integer here. So now if I create, actually all these cats here, okay, they're not here anymore. We were creating them inside the main function. So let's create this cat. Okay, I don't need this call here. Cat2, cat3, and okay, let's just create an array of cats. And okay, I'm going to print the cats. They should have now, because we're using the default constructor, they should have a name saying cat plus a number starting with 0, incrementing by 1 at every step. And then the print function should say, I am a cat and my name is whatever the name is. Now, you're all familiar with the for loop I did before, where we start at 0 and we go through every, like this one here. Start at 0 and then I less than cats.size, I++. It's a basic for loop. However, there are other for loops that they are well used in, especially modern C++. And whenever you're dealing with a container, something holding, like something part of the standard library that has an iterator. You're going to look at iterators maybe at the very last lecture in this course, but let me show you what I mean. So auto, let's say, okay, so this is another form of for loop that you probably, I don't know if you've seen it before, but maybe get used to it because it comes really helpful. So what this is doing is that it's basically going through every element inside the array cats. So this is like for each element inside cats, give me a constant reference of that object. So, okay, let me not use auto here, let me not confuse everything. So for each element inside cats, give me an object called cat, which is a constant reference to that element. So it's going to start with the very first element, and then it's going to keep moving one element at a time. And at every step, we have this cat variable name here, which is a constant reference because we're specifying it's a constant reference. It's a constant reference to that element inside that array. So if I do cat.print, okay, I'm getting an error here because I'm specifying that this is a constant reference, but my print function is not constant. So I cannot make a call to a function that is not constant if my object is constant. And this is something we discussed last time, in which we specified why it's important to any function that is constant has to stay constant. Any function that, like all the getters, for example, has to be constant, which means that this function does not allow to change anything in the class. So now it works. I'm going to run this, and then we're going to look at like more details about what's happening inside this for loop. Okay, this is not working at all. We have, I mean, it's working, but the number is not working. The naming is not working. So we have is cat, blah, blah. So, okay, I know why. Because this is not how you add strings together, especially with numbers. So in here, what I'm doing, where is it? Here. I'm adding to this string a number. And I think what I need to do is string to integer, actually integer to string. There's a function in the standard library to change an integer to string. Okay, to string. Should have tried that first. So std to string. Okay, so now we're changing this number to a string and we're adding it to a cat string, and we're creating a new object of string and storing it in name. I think this should solve the problem. Okay, so things are working. Like the problem here was that I was adding an integer to an array that I'm writing myself, which is basically going to be compiled to a constant character array. And we know that when we're dealing with arrays, we have a pointer to the first element. So if I'm adding an integer to it, I'm basically moving the pointer into other elements. And if you notice before, what was happening in the output, it was starting with cat, and then it start as AT, then T, then spaces. So it was like basically moving through that array based on that incrementation of the number, which we definitely didn't want to do that. So I had to use the function toString from the standard library, which will take an integer and return a string of that, like basically ASCII character of the number. If you know what the ASCII characters are. So ASCII is a like a way to store Okay, so 1, for example, 1 as a digit, it will have the value of, in decimal or in hexa, 1 as a digit, it will have the value of 31 in hexadecimals in the ASCII table. Anyway, where were we? Okay, so in this case, the static integer number of cats was incremented at every step, and it was shared with all the cat class. So at every construction of a new object of class of cat, we were able to use it to create a new name for the cat with this signature name, with a signature number, and we're incrementing it. So anytime, anywhere we are creating a new object of cat using the default constructor, as long as we're in the same runtime of our program, of course, but from whoever inside our program is creating a new cat object using the default constructor, it's going to increment, it's going to have a unique number because we're keeping track of the number of cats statically, like it's shared within the whole class, and we're incrementing it at every step. Is this part clear about static members? Because I think the for loop was not clear to everyone. So anyone have any question about static members before we move on to that for loop again? Okay. Anyone did not get this for loop right here? Or anyone wants me to repeat? Okay, let me ask you this. What's the difference between what I had before and this right now? Like it. before I had a constant reference to a cat object. I'm not sure what I pressed. So before I had a constant reference to a cat object. So every element we are going through this cats array is going to be returned as a constant reference. And if I do this, how will it be returned, that element from the array? It's going to be returned by value. So what that means, so actually let's modify our cat here. Let's allow a way to set the name. Void set name, and let's pass a string name. Because we have like, we're going to use this keyword, which we discussed it last time. This keyword is a pointer to the object we are in right now. And we're saying that the name member of our object right now is going to be equal to this name we're passing here. So I'm going to go into this for loop, and I'm going to set the name to whatever. Okay, I'm going to go through all the cats, and I'm going to set the name to whatever. Now this is what I'm going to do again. I'm going to go through another for loop separately of the same array. This is the same array. And I'm going to print the values. So what I would expect to happen, because I'm calling set name, is that I expect the cats inside array to be changed. The name should change. But I still have the same old names, cat0, cat1, cat2. With my first for loop, all the cats' names should change to whatever. Like literally whatever. Why are they not changing? So inside this for loop, we are returning every single element in this array of cats one by one, and we are returning it by value. So what that means is that this object cat that we're getting here is a copy of whatever inside that array element, and it's not the actual array element. So we're setting the name to a copy and not to the elements inside the array. So when we are going back to the same array and we are printing the values never changed because we are dealing with a copy and not the actual cat. We're dealing with a copycat. Okay, so if we're passing this by reference now, we're passing the cat by reference, and we're setting the name of this cat, which means we are returning the element inside this array by reference, and we're not making a copy of it. And we're setting its name, and then we go through the array again of cats and we're printing, we should see the name change. And now we have a bunch of copycats, which is like whatever and not the actual copy. So the names actually changed here because we are passing things by reference, and we got access to the elements inside the array. Now, usually, if you're just reading information, you're using this for loop, you will return things by constant reference because Like right now, we cannot do this because we're changing something. We're calling set name. So we cannot call things by constant reference. But if actually here, if you're just reading, you would return things by constant reference, which will be more efficient because it doesn't have to make copies of anything, and you're just reading. If you're writing something and you're modifying something and you are using this kind of for loop, you need to make sure that you're passing things by reference, because if you pass them by value, you'll be changing a copy and not the actual elements inside the array. Now, at the beginning, I wrote this with an auto keyword. I probably mentioned what is the auto keyword before. The compiler will automatically detect the type of this auto keyword because it knows what is my type here. It knows the type of this array. And the type of this array is going to be the same as the type of the element I'm returning. So this auto here, it says actually the IDE is able to identify even that it has class cat, because the compiler will know, because this is what it will be returned from the array. So it's usually like a easy shortcut, like just to write constant auto reference, which it will automatically detect it. So do you guys have any questions before we take the attendance and just leave? Okay, I'm gonna assume you don't have any questions. So I just shared the link to the form. Please go in and sign your attendance.